Okay, let us see or let us apply the results that we have learned now to obtain the position and nature of image formed by a concave mirror. Let us see. First of all, let us consider a situation where the object is at infinity. Object, what does it mean by this object at infinity? Object is at infinity means the object is placed at a distance very large compared to the focal length of the mirror. Mirror and focal length apekshichu valiya oru distance ilanu nammal object vekkunnathu. Suppose this is our concave mirror. Okay, this is our concave mirror. Now what we are doing is we are placing the object at infinitely large distance. When we place the object at infinitely large distance, the light rays coming from the object are almost parallel like this. Okay, they are parallel and they are parallel to the principal axis. Okay, ഒത്തിരി ദൂരം നിന്ന് വരുന്ന light rays, what are their nature? They are parallel to each other and parallel to the principal axis. And what happens to them after their reflection? They will pass through the focus. Okay, they will pass through the focus. You can see it like this. Okay, I hope that is clear. So what we have is a real image. A real image. Why do we call it a real image? Because the light rays are actually meeting. If we place a screen over here, we will get a clear image on that screen. If the light rays are coming from the sun, by placing a mirror over here, we can obtain a real image on the focus. Okay, the light will be concentrated over to that point. We have a real image. Then what are the other properties? The image is highly diminished. Okay, valare ചെറിയ ഒരു പോയിന്റ് സൈസ്ഡ് ഇമേജ് ആണ് അവിടെ ഉണ്ടാകുന്നത്. ഇമേജ് ഇസ് ഹൈലി ഡിമിനിഷ്ഡ്. ആൻഡ് അനദർ പ്രോപ്പർട്ടി ഇസ് ദാറ്റ് ദി ഇമേജ് ഇസ് ഫോംഡ് അറ്റ് എഫ്. സോ ഇഫ് ദി ഒബ്ജക്റ്റ് ഇസ് പ്ലേസ്ഡ് അറ്റ് ഇൻഫിനിറ്റി if the object is placed at very large distance from the principal axis, very large distance from the mirror, the image obtained is at focus, the image is highly diminished and it is a real image. So you can see over here, so we are going to place the object very far, that is what we mean by infinity. And you can see that the pole center of curvature, the light rays, object is placed very far, not a comparable distance. So ഒത്തിരി ദൂരെ ഇരിക്കുന്ന object തന്നെയാണ്. And you can see that these light rays after reflection, they are formed at the focus. They are meeting at the focus എന്ന് നമുക്ക് വേണമെങ്കിൽ പറയാം. ശരിയല്ലേ? ഒരു inverted highly diminished image ആയിരിക്കും നമുക്ക് ഇവിടെ കിട്ടുക. Okay, എന്താണ് inverted highly diminished image? Let us also look at the properties of images. എന്തൊക്കെയാണ് properties, characteristics of image? എന്താണ്? It is real and inverted image, highly diminished, and what is the nature? It is formed, or what is the position? It is formed at the focus. Okay, I hope that is clear. Focusൽ തന്നെ image ഉണ്ടാവുകയാണ്. Okay, I hope that is clear. Now so that was the case when the object is placed at infinity. Now let us look at the case where the object is not placed infinity, but it is placed a little beyond the sea. Okay, object is placed beyond the sea. Okay, here what happens is object is not placed at infinity, instead it is placed somewhere over here. This is how we represent the object. Okay, ഇങ്ങനെയാണ് നമ്മൾ ഒബ്ജക്റ്റിനെ റെപ്രസെന്റ് ചെയ്യുക. So it is placed at some distance from the focus. ഫോക്കസിൽ നിന്ന് കുറച്ച് ദൂരെയാണ് നമ്മൾ സെന്റർ ഓഫ് കർവേച്ചർ നിന്ന് കുറച്ച് ദൂരെയാണ് നമ്മൾ ഒബ്ജക്റ്റ് വെക്കുക. So how do we find the image? How do we find the image? We will consider at least two rays starting from the object. Okay, object എന്നുള്ള ഒരു ലൈറ്റ് റേ ഇങ്ങനെയാണ്. ആഫ്റ്റർ റിഫ്ലക്ഷൻ ഇറ്റ് വിൽ പാസ് ത്രൂ ദി പ്രിൻസിപ്പൽ ഫോക്കസ് ലൈക്ക് ദിസ്. Okay, the light ray will pass through the principal focus. And what about the second light ray? How can we take the second light ray? Second light ray, you can take it to be passing through F or passing through center of curvature, or we can consider it to be like this. the one that is incident on the pole. Okay, one that is incident on the pole. What will happen to the light rays that are incident on the pole? They will be reflected. They will be reflected. Yes, symmetrically. So, because this is normal, this is angle of incidence, this is angle of a reflection, so they will meet over here. Okay, so the light rays starting from this point, the tip of the object, they meet at this point. So this will be the tip of the image. Okay, but tip of the image, image is going to be like this. So we will have an inverted image between C and F. So the object is placed beyond C. The image, what are the nature of the image? First one, and the location between C and F. Okay, the image is formed between C and F. Second one, so image is formed between C and F. And what are the other nature? The light rays are actually meeting, so it is a real image. Okay, light rays are actually meeting, it is a real image. Then what are the other properties? Next property is the images. You can see that with respect to the object, the image is inverted. So it is an inverted image. Okay, what is it? It is an inverted image. Okay, so we have a real image, inverted image, and what about the size of the image? You can see that the size of the image is smaller compared to the size of the object, right? Object and image in the size. If the size of the image is smaller, then we can call it a diminished image. So image is formed between C and F. It is a real image, it is an inverted image, it is a diminished image. Okay, so let's look at that again. So here we are going to place the object beyond C. So the object is placed beyond C, and see what happens to the light rays. Here they are considering two different light rays. Okay, we consider the light ray, this is in another way. What we considered is two light rays. Okay, one parallel to the principal axis and the other incident on the pole. Okay, but what here we have considered one light ray parallel to the principal axis and the second light ray, it is passing through the focus. Anything is fine, no problem with that. Okay, we'll get the same location of the image. You can see that the light rays are actually meeting at a point between C and F. So you can see the light rays are meeting at this point, and even though we use this one, even if we use this light ray, we would get the same answer. Even if we would use this light ray, we would get the same answer. It would meet at the exact same point. Now let us talk about the characteristics of images. We have already discussed that. So you can see it, real and inverted image, diminished image, position between C and F. Real, inverted, diminished between C and F. I hope that is clear. Okay, so if we place a screen over here, we will get an inverted image of the screen, of the object. Now, so here, what is the condition? Object is placed beyond the C. Let us look at the next condition, object at C. Okay, so initially the object was placed at infinitely large distance, right? Okay, initially the object is placed at infinitely large distance. Now after that we brought it to this position that is just beyond C. After that we are moving this object close to the mirror. So we are moving the object close to the mirror beyond C. Now it is at C. Let's see what happens when the object is placed at C. Okay, what happens when the object is placed at C? We will use the same techniques that we used earlier. One is that the light rays incident on the light rays parallel to the principal axis, after reflection will pass through the focus. What happens to the light rays parallel to the principal axis? After reflection they will pass through the focus. Light rays parallel to the principal axis will pass through the focus after reflection. And what about the light rays incident at the pole? Light rays incident at the pole are reflected symmetrically. If they are reflected symmetrically, we can say that they will meet at this point. Okay, once again, the light rays starting from the tip of the object meets again at the tip of the image. So, this point is A എന്ന് വിളിച്ചാൽ A എന്ന് start ചെയ്ത light rays വീണ്ടും meet ചെയ്യുന്നുണ്ടെങ്കിൽ അത് A യുടെ image ആയിരിക്കും. If this point is A, if the light rays starting from A meet again, then that meeting point is the image of A. So the image of the object is going to be like this. Okay, so this is the image of the object, this is the object, and this is the image. So what are the properties of image? Properties and nature and location. What are the properties of image? The first property is its location. It is formed at C. Where is the image formed? The image is formed at C. Now the next property. Whether it is real or virtual. The light rays are actually meeting at this point, right? Light rays are actually meeting. So this is a real image. Now third property. Is it upright or inverted? This is the image. It is inverted with respect to the object. So it is an inverted image. Okay, now the fourth property, what about its size? You can see from this that the size of the image is equal to the size of the object. So we can say it is not diminished, it is not enlarged. We can say same size as that of the object. Okay, so same size as that of the object. Upon the Shradhikya, properties and what happens to the, so we can say we have a real inverted image of same size as that of the object formed at the location of the object itself. So when do the object and image coincide? In the case of a concave mirror, when the object is placed at C. Object C il vekkumbozhana objectum imageum ore sthalathu variya. Okay, let us analyze that again. So here what are we going to do? We are going to place an object at C itself. Okay, we are going to place an object at C itself. So let us look at the image formation. So here the object is placed at C. You can see that there are two light rays. It is not like I have taken. What I have taken two light rays, one passing through or one incident at the pole and the other parallel to the principal axis. Whereas in this case, they have taken two light rays, one parallel to the principal axis and the other parallel to other passing through the focus. It doesn't matter. Okay, result. You can see that the light rays are actually meeting over here and the image is formed at C itself, and we have an image whose position and size are exactly same as that of the object. The only thing that differs is one thing, it is inverted. That is the only difference. So let us look at the properties. So what are the characteristics? Real and inverted image, same size as that of the object. And what about the position? Position is at C itself, right? So that is one interesting thing. So initially, when we place the object at C, the image was between C and F, right? Now, when we moved the object to C, the image, what happened to the image? Image also moves to C, and its size is also same as that of the object. Okay, so when the object moved from beyond C to C, the image moved from between C and F to C. Okay, the object moved from beyond C to C, the image moved from between C and F to C. Okay, I hope that is clear. Let us look at the next possibility. This is object at C. Now let us again bring this object closer to the mirror, that is object between C and F. Okay, object between C and F, let us see. So first case, in the first case the object was very far away from the mirror, then it was moved to beyond C, now then we moved it to C, and after that now we are going to move it to a position between C and F. Okay, so between C and F we have an object. So let us draw the ray diagram. What are the rules for drawing ray diagram? One light ray that is parallel to the principal axis after reflection should pass through the focus. Okay, the next light ray that is passing, you can use any two of these rules. The light ray that is incident on the pole, that will be reflected symmetrically like this. Okay, it will be symmetrically reflected, so the light rays are meeting over here. So the light rays starting from the object, they meet again at this point. So this is the image. Light rays are actually meeting, so we have a real inverted image. Okay, you can see that the image is formed beyond C. Okay, image is formed beyond C. So let us analyze the nature of the image. Okay, what are the properties of image? For one thing is, it is real and inverted. Okay, real and inverted, and you can see that it is enlarged. Okay, so the image is real, inverted, enlarged, and what about the nature? What about the location? It is beyond C. So we have an enlarged image. Like the size of the image is larger compared to that of the object, right? Yes, size of the image is larger compared to that of the object, and it is real. How do we say that it is real? Because light rays are actually meeting, and we have its location is beyond C. It is some kind of symmetry involved in this, right? That is, if the object is placed beyond C, image is formed between C and F, a small image. Okay. Now, if the object is placed between C and F, image is formed beyond C, right? Yes. Now, let us analyze that once again. Okay. Now, let us look at a case let's look at it again, where the object is placed between C and F. So, C kum F num edakku nammal object vechu. Okay. So, let us see which are the light rays that they consider first. Okay, one light ray that they have considered is the light ray parallel to the principal axis, and the second one is the light ray that is incident on the pole, just like we have taken. Then they will get reflected, and you can see that they are meeting at this point. So this is a real, inverted. So by real image, I mean that the light rays are actually meeting. If I place a screen over here, if I place a piece of paper, a paper sheet over here, I'll get a clear image of that. Okay, and it is enlarged beyond C. Okay, the image is enlarged, unlike the previous cases that we have seen. So let us continue. Let us see the characteristics of images as well. So what are the characteristics of image? Real and inverted image, enlarged image, and the position is beyond C. So once again, when you are watching this class, make sure that with each of these examples, you pause the video, you draw these diagrams by yourself, and you try to understand the things. Okay? With the pause video, you can pause it to സ്വന്തമായിട്ട് അത് മനസ്സിലാക്കാനായിട്ട് ശ്രമിക്കുക, സ്വന്തമായിട്ട് വരയ്ക്കാനായിട്ട് ശ്രമിക്കുക. Okay? Then, അടുത്ത situation. This is object between C and F. So we have moved object like this. So between C and F where I, now we'll move it on to focus. So object at F. Okay, object is placed at F. Object ആദ്യം ഇൻഫിനിറ്റിയിലായിരുന്നു, ഞാൻ then C യുടെ പുറത്തേക്ക് കൊണ്ടുവന്നു. Then we moved it to C, between C and F. Now it is F. So the object is at F. Let us consider the light rays. One light ray that is parallel to the principal axis, it will be, after reflection, it will pass to the focus. And another light ray that is going to be incident on the pole. Let's see what happens to this after the reflection. If these light rays incident on the pole are reflected, they will be reflected symmetrically, and you can see that these light rays, they are parallel to each other after reflection. Right? These light rays are parallel to each other after reflection, and if they are parallel to each other, you have learned about the properties of parallel lines. Parallel lines will meet only at infinity. So if these light rays are parallel to each other, they are going to meet only at infinity. So we can say they will meet at infinity. Okay, they will meet at infinity. So where is the image formed? There is a highly enlarged inverted image at infinity. Okay, highly enlarged inverted image at infinity when the object is placed at focus. Okay, so let us analyze that again. So object, when it is at F, once again let us see what happens. So here the object is placed at F, and the light rays that they have taken are just like that we have taken. One is parallel to the principal axis and the other one is incident on the pole. After reflection, they are parallel to each other. So we can say parallel lines meet only at infinity. So the image is at infinity. So we have a real inverted image, highly enlarged image whose location is at infinity. So just like we have predicted, or we have seen what happens, or what is the nature of the image, real and inverted image is formed at infinity and it is highly enlarged.